AP Calculus AB presents Selling Calculus.
Good evening, calculus students. Are you struggling with those pesky derivatives? Fear not, because we have the ultimate solution for you: integrals. Our revolutionary new product comes in exciting new versions: the indefinite and the definite version. Integrals are designed to help you get rid of those pesky derivatives. It may leave unwanted constants behind, but on the other hand, the definite version of the integrals would fully undo your derivative problem and give you a definite answer along with it. And the best part, the definite version of the integrals can even be used to find the volume of functions and remove some too, if you're dealing with washers.
Cut to a washer.
Now, let's take a closer look at the calculus concepts behind integrals. Derivatives are used to help us find the instantaneous rate of change of a function at any given point. For example, if you're looking for the velocity of a moving object, you can find the derivative of its position function determine its instantaneous velocity at any specific time. However, derivatives have their limitations. Now, they only tell us the instantaneous rate of change at any given point and not the total change over an interval. But wait, there's more. Integrals can be used to find the area underneath a curve, which is a fundamental theorem in calculus.
Now let's talk about some other calculus terms, such as limits, a concept used to describe the behavior of a function as the input approaches a certain value. Then, on the other hand, we have functions, which are simply a set of inputs and outputs. Moving on, we have derivatives, which are used to find the instantaneous rate of a function at any given point, such as finding slope, velocity, and acceleration. The chain rule and product rule are two techniques used to find derivatives of a more complex function. The function of these derivatives must be continuous. This means that there are no holes or jumps. This also means that for any value of the function, the left-hand limit and right-hand limit must be equal to each other. These are some of the basic rules of continuity. Along with being continuous, the functions must be differentiable. This means that along with following the rules of continuity, this must also have no sharp turns or vertical tangent lines.
Next, we have integrations and Riemann sums. Integrations, which are the inverse operation of differentiation. This is the process of finding the area under a curve, which is represented by the integral symbol. We also have Riemann sums, which are a way of approximating the area under a curve by dividing it into smaller and smaller pieces.
But calculus doesn't just involve functions and curves, it also involves shapes. The volume of a three-dimensional shape can also be calculated using integration, which is especially useful when dealing with irregular shapes. This is commonly referred to as the washer method or the shell method.
Last but not least, we have differentiable equations. Equations that involve derivatives. These are used to model the real-world phenomena like population growth, radioactive decay, and electrical circuits. They're also a key concept in many areas of science and engineering.
So there you have it, calculus students. Integrals is the ultimate tool for mastering calculus, but don't forget about all the other important concepts we discussed. Remember, there are many resources available to help you learn calculus, such as textbooks, online tutorials, and study groups. Thank you for tuning in for our calculus newscast. Happy calculus.
Say 3, 2, 1.
Say 3, 2, 1.
3, 2, 1. But wait!
Wait.